when I did it the first way, oops, I was trying to do highlighter, not marker, okay. I got root 6 plus root 2 over 4. Raise your hand if you got that. Root 6 plus root 2 over 4. But we know, again, that addition can be switched, okay? So if you do it the second way where you're subtracting 150 minus 45, here you end up subtracting a negative, and when you subtract a negative, because the cosine of 150 is negative root 3 over 2, when you subtract the negative, it changes to addition. But again, you get the same answer. So either one of those answers would be acceptable. Any questions? All right, let's move on to tangent. So the tangent, again, those are a lot. Okay, because we have a fraction now. So tangent sum and tangent difference, we have a fraction. So what this says is in the numerator, we take the tangent of alpha plus the tangent of beta and divide that by 1 minus tangent alpha times tangent beta. So I'm going to tell you, probably should lock in because these two, it's a lot of work. Okay, so I see a lot of phones out. We might want to put those away and just make sure we're really locked in, because the tangent one, as always, is just a whole lot. All right, so let's go ahead and start with this one. Tangent of 7 pi over 12. Go ahead and copy that down. And we need to figure out our two angles that we're going to add to get to 7 pi over 12. Or subtract. We could add or subtract. But for this first one, I set it up to do addition. Okay, so I feel like we've done a lot of 7 pi over 12. What would be our two angles that we would add? Pi over 4 and pi over 3. So we know we can break this apart to 3 pi over 12 plus 4 pi over 12. And I should probably write the bigger one first. Hold on, let me switch that. Not that it matters, but just trying to be consistent. Okay, again, addition doesn't matter. So 4 over 12 reduces down to pi over 3. So we have the tangent of pi over 3 plus the tangent of pi over 4. So we're taking pi over 3 plus pi over 4. So before we even get started with this identity over here, before I even get started looking at this, we need to start by identifying the tangent of pi over 3. And we need to know the tangent of pi over 4. Well, pi over 4 is pretty easy, right? What is the tangent of pi over 4? That's 1. That's pretty easy. So we can write that down. Pi over 4, you have root 2 over 2 divided by root 2 over 2, which gives you 1. All right, what do you think the tangent of pi over 3 would be? It's either root 3 or root 3 over 3. And I really like the way, so if you think about it as far as slope, and if you don't know, because like if you're not able to recognize what it is, then just do your keep change flip. But if you were to take sine of, if you're not sure what it is, then just go the long way. Take the sine of pi over 3 and divide that by the cosine of pi over 3. Because I know the shortcut, but if you don't know it at this point, I would rather you go the long way to get the tangent than to do the shortcut. So I'll give you a minute to do that. Figure out what that is. Take out your unit circle. If you don't know what it is yet, take the sine of pi over 3 and divide that by the cosine of pi over 3. And do your keep change flip. All right, did you all get root 3? All right, so we got root 3. So now we have these two. So we know in our formula that wherever it says tangent of alpha, because in our example, alpha is pi over 3, the tangent of alpha is root 3. And the tangent of beta equals 1. So let's go ahead and fill in this identity. Every place where there is a tangent alpha, I want you to put root 3. And every place where you see tangent beta, put a positive 1. So let's go ahead and fill in this identity, which is on your pink sheet in the first column. So I have the square root of 3 plus 1 all over 1 minus root 3 times 1. And then let me pull this up for people to see. So that's where we are. Okay, so when you're adding two numbers, order does not matter. Okay, because 5 plus 2 would be 7, and so would 2 plus 5. When you're subtracting, though, it does matter. Okay. Yes, is 2 minus 5 the same as 5 minus 2? You get different numbers, right? Order matters. So, okay, so let's go ahead and simplify this out. This is where the whole lotta comes. So we have root 3 plus 1 all over 1 minus, and then what is the square root of 3 times 1? Anything times 1 is just going to be, yeah, the square root of 3. But we have a problem, as tangent always has. What do we have? Not a negative, because you can have a negative in your denominator, but what can't you have? A square root. We have to rationalize this. I told you, I said tangent is the cousin that always brings a lot of drama. It's work, okay? So what we have to do is multiply by the conjugate of my denominator. The conjugate of 1 minus root 3 would be 1 plus root 3. So top and bottom. That's what we're going to multiply by. All right, so let's go ahead and start with the numerator. Let's multiply these two. And we're going to make a box. So I'll give you a minute to do that. For the numerator, I'm making my box. And I'm multiplying the square root of 3 plus 1 times 1 plus the square root of 3. All right, take a 60 minutes. 60 minutes. I didn't mean to say that. We don't have 60 minutes. 60 seconds. Filling out 4 squares. Okay, who had that in their 4 boxes? All right, good. Okay, so we have, these two are like terms. Now remember that in front, they both have a coefficient of 1, so we can put a 1 right here and here. So when I add that together, 1 root 3 plus 1 root 3, that's like 1x plus 1x, which would be 2x. So 1 root 3 plus 1 root 3 is 2 root 3. So I'm just putting my answer up to the front. This is my answer. So I have 2 root 3. And then I'm going to add these 2 squares. So that's what I get when I add these 2 squares. And when I add these 2 squares, I didn't show this, but the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Just in case anybody's wondering how I got 3. And then we have 3 plus 1, which gives you a 4. All right, so now let's do our denominator. So that's going to give you, you're going to take 1 minus the square root of 3 times 1 plus the square root of 3. Go ahead and fill in all 4 squares. All right, so when you fill this in, you have a positive 1, and then you have a negative root 3, a positive root 3, and then this would be a negative square root of 9, which ends up being just a negative 3. So the reason why we did this is because we wanted to cancel our square roots. And do you see how that happens here? When you multiply a positive root 3 by a negative root 3, that's like x minus x, you get a 0 pair, it cancels. So you're left with just 1 minus 3, which would be what? What is 1 minus 3? Negative 2. Okay, this is an ugly square root. I gotta fix that. All right, anything else we can do here? What'd you say, Marissa? Yeah, you could, but you not just cancel out the 2. Really what you can do is divide these numbers by negative 2 and then divide these numbers by negative 2. So your final answer would be 2 divided by negative 2, which is a negative 1, negative root 3, plus 4 divided by negative 2, which is a negative 2. Or you could just write that as negative root 3 minus 2. And that would be your final answer. So like I said, tangent takes a lot of work. Now, if you happen to leave it here, I will still give you the majority of your points. So if it's probably worth 5 points, I would give you 4.5. So not simplifying it fully will only cost you a half of a point. But one of these answers would be your best answer. So what I did was I took that 2. You have to divide both of the numbers by your denominator. Not just the 2, but the 4 also. All right, so now we see why tangent brings the drama, right? It's a whole lot of work. So let's do one more. Tangent of 15. I think this one's, there's a lot of angles we could use, but I want us to subtract. We can't add to get to 15 because we don't have any angles less than 15. Well, I guess we could if we use some negative angles, but let's not make it complicated like that. Okay. So what 2 angles do you want to subtract to get to 15 degrees? 45 and 30. Who thinks 45 and 30? Anyone think 60 and 45? Okay, either one will work. I'm going to do 45 and 30 because that one's a little bit harder. So you can see, because the tangent of a 30 is root 3 over 3. So let's do that one, even though it's going to be more work, okay? So that you can see in the future. Because tangent of just 60 degrees is just the square root of 3. but the tangent of 30 degrees is root 3 over 3. And I'm not sure which one we gave you on the test, so let's just look at it. So we're going to do the tangent of 45 minus 30. So 45 is my alpha, 30 is my beta. So we need to start by figuring out the tangent of 45, which is 1. That's easy. And we know the tangent of 30 is equal to the sine of 30 divided by cosine of 30, which if you did the work would give you root 3 over 3. So those are my two tangent values. So every place where it says tangent of alpha, we're going to put a 1. So that would be here and here. And every place where it says tangent of beta, we're going to put a root 3 over 3. Here and here. So let's go ahead and do it. So if I have the tangent of my tangent of 15 is going to equal tangent of, here, let me actually take that off. So it's going to equal tangent of alpha, which is 1, minus root 3 over 3. And that's going to be divided by 1 plus, and it would be 1 times root 3 over 3. What did you say, Marissa? It is ugly. It's ugly. We're going to work through it, though. This is our last question. Tangent, like I said, I know it takes a lot for tangent, so I just kind of gave it its whole one day. It gets its own day because it's a lot. It's a lot. It's always been a lot since the beginning. No. So we're only working with the identities you see on the back. So, yeah. The bigger one is alpha. Yes. And the smaller one is beta. Good question. So because 45 is bigger, then it would be alpha. Now, if I did 60 minus 45, 60 would have been my alpha and 45 would have been my beta. But we're going to do this the hard way since it's our last one. We're going to just, put in the work. Okay. So let's go ahead and do our numerator first. So we got 1 minus root 3 over 3. I need to have a common denominator. So I can't subtract 1 from that. So I'm going to rewrite this as 3. Instead of 1, I'm going to write that as 3 over 3 minus root 3 over 3. Do you agree that 3 divided by 3 is the same thing as 1? Okay, I'm just writing it so I have a common denominator. So that's going to change my numerator to, kind of running out of space. So I'm going to take this off because you already got that down. Okay, so that's my numerator is just going to end up being 3 minus root 3 over 3. So we're going to let that cook on the stove. Let's look at our denominator. For my denominator, I have this. This is going to multiply to give me positive root 3 over 3. So I have 1 plus root 3 over 3. But again, I can't add these right now because that's a 1. And I need to rewrite the 1 as what? 3 over 3. Which is going to give me 3 plus root 3 over 3. So I'm going to pause right there for you all to catch up with me. Make sure we're all together. This is an ugly one. It's ugly. But it's okay. We got it. So I'm going to divide these two. I'm going to do a keep, change, flip. So I'm going to keep my numerator the same. So my numerator is going to stay 3 . Okay, so my numerator is going to stay 3 minus root 3 over 3. And instead of dividing, it changes to multiplication. And it becomes 3 over 3 plus root 3. Does everyone see that keep, change, flip? So this is my numerator. Okay, I'm getting confused with my highlighter and my eraser. This is my numerator. This is my denominator. So I kept the numerator the same. Then I changed it from a fraction is division. So I changed it from division to multiplication. And then I flipped. So what's going to happen when I do that are the 3's will cancel. And that's going to leave me with 3 minus root 3 over 3 plus root 3.
I have a question.
Yes.
That one that was just right there.
Okay, right here.
Yeah.
So right here. So then I changed the 1 to 3 over 3.
All right.
Because you can't add two fractions.
That's already multiplied to 3 over 3.
Yeah, because if you multiply 1 times root 3 over 3, you still get root 3 over 3. Thank you for asking that question. I want to make sure we're all together. Now we're almost to the finish line. What do you think I have to do now? Multiply by what? What am I multiplying by to get rid of this? 3 minus root 3 over 3. You always flip the sign of your denominator. If I'm trying to cancel my denominator, I flip the sign of my denominator. So that's our last step. Go ahead and make your 2 boxes. I did not mean to put a plus. After I just told you to flip it, I kept it a plus. Hold on. It's 3 minus. Me and technology are not getting along today. 3 minus root 3. Top and bottom. 3 minus root 3. Go ahead and make your 2 boxes and you are finished. For your numerator, you're multiplying these 2. So let's start with that. Go ahead, fill in all 4 squares. So that would be a 9. Now, when you're multiplying this is like saying 3 times x. So it's, or 3 times negative x. So that's, in this square, it's going to be a negative 3 root 3. And the same thing here. And in this square, you're going to have a negative 3. It would be, because 2 negatives make a positive. Thank you so much. You are right. Alrighty, so let's go ahead and combine our like terms. So we have these 2. They're like terms. And then these 2 are like terms. So my numerator, let's see, where am I going to write that? I'm going to write it over here. My final answer. All right, so my numerator would be negative 6 root 3 plus 12. That's my numerator. So now let's figure out our denominator. Let's make a box. And when we multiply our denominator, we're multiplying these 2 that I have highlighted in yellow. Using lots of colors to help organize it. So 3 plus root 3 over 3 minus root 3. So that would be a 9. 3 root 3 negative root 3, and then negative 3. And then our like terms are just these two. And this cancels. So what would be in my denominator? What do I have left to put in my denominator? A 6. So if you got to that part, I'm proud of you. You did amazing. Good job. Give yourself a pat on the back. But you gotta simplify it to get. If you want to get the gold, you gotta go that little extra. We had a good silver right now, though. Silver is good. So I'm going to divide these two numbers. So negative 6 divided by 6 would give me a negative 1 root 3. And then I'm going to do the same thing and divide these two numbers. And 12 divided by 6 is 2. Oh, and it looks like a little heart, kind of. Oh, there's love in the air. Now, just know, too, that this could also have been written as 2 minus. So these two can reverse. So I think I should also add that this is the exact, because on the calculator, if you were to type in, let me see, how does it say in the calculator? I think the calculator always puts the number first. Tangent of 15. I don't know, I wrote it like that, negative root 3 plus 2. And you can verify it with the yellow calculator. That's why you don't get to use it on the test. But if the yellow calculator, if you type in tangent of 15, that's what you get. But what I was going to say is that if you wrote it this way, I would still give you full credit. That's where I was going. All right. So use this time. Let's finish out homework 10. Get it turned in early. You only got 2 questions left for 2 tangents. And then you're done. You can turn that in today.